Okay, let's unpack this. Welcome to the deep dive. Today, we are plunging headfirst into a stack of sources you've shared, all revolving around preparing for the Azure AI 102 exam. This isn't just about passing a test, though. This material gives us a fantastic, practical look at the core Azure AI services and fundamental concepts you'd actually use,
Yeah.
to build intelligent solutions in the real world.
Exactly. Our mission for this deep dive is to go beyond just listing facts. We want to unpack these practice questions, understand why specific Azure services are the right tools for these different AI tasks, and, well, what makes them particularly effective.
Yeah, the sources give us a quick rundown on the exam itself. The basics, like it's administered through Pearson VUE, typically runs about 2 hours, has maybe 40 to 60 questions, and you need a 700 out of the 1,000 or 70% to pass. It's offered in English and a whole bunch of other languages. Good stuff to know, but
But the real meat, like you said, is in these 10 practice questions and their explanations. They are essentially mini case studies, showing how Azure AI services tackle specific problems. They give you the context, the challenge, and then point straight to the solution. Let's just jump right into the first one, see what we can learn.
sounds good.
Yeah.
Let's start with a common business challenge.
Yeah.
Dealing with paper or, scanned documents. Scenario 1, question 1, describes developing a system to extract tables and key fields from scanned tax forms.
Okay.
The question is, which Azure service is built for this specific task? And the correct answer is Form Recognizer.
Yeah, and what's interesting here is that while you could maybe use basic optical character recognition, OCR, Form Recognizer goes much, much deeper. It's explicitly designed to understand the structure of documents.
That's for sure.
Like forms, receipts, invoices. It doesn't just read the text. It identifies key value pairs, tables, structured data, even within really complex layouts.
Ah, okay.
So for something like a tax form where you absolutely need to pull out specific numbered fields and whole tables, Form Recognizer is the service that can actually make sense of it automatically.
So it's not just seeing the letters and words. It's understanding that line 7 goes with adjusted gross income or whatever.
Exactly.
And knowing that a grid of numbers is a table you need to grab.
Yeah.
That level of structural awareness, that's the key thing here.
Precisely. It handles the messiness of real-world documents.
Okay, shifting gears a bit, from static documents to dynamic content. Scenario 2, question 2. This one deals with video. You're building a video archive using Azure Video Indexer, and you need to detect inappropriate content like violence or adult themes for content moderation purposes. What do you enable within Video Indexer? The answer is simply content moderation.
And this really highlights one of Video Indexer's powerful built-in capabilities. If you're dealing with user-generated content or just a massive library of video, manually reviewing everything for compliance or safety is it's impossible.
Yeah, no way.
Video Indexer includes AI models specifically trained to detect adult content flags, violence, other kinds of signals. Enabling this feature automatically scans your video assets. It saves immense time and effort. It's right there, integrated, ready to go.
So it's not like some extra thing you have to build from scratch. It's a pre-packaged AI feature you just turn on for your video analysis pipeline.
Exactly that. It makes content safety and compliance much, much more manageable, especially at scale.
All right, moving from video to language barriers.
Yeah.
Scenario 3, question 3. You need to translate emails received in various languages into English. Which Azure Cognitive Service is your go-to for this? That would be the translator service.
This is maybe one of the more straightforward ones, but it's incredibly powerful. Azure Translator provides fast, scalable, and pretty accurate text translation between a huge number of languages.
Right.
And unlike just simple lookups, it uses neural machine translation, which means you get more natural and contextually appropriate translations. So if you're processing communications, support tickets, emails from all over the globe, plugging them into Translator is really the most effective way to understand them in your preferred language.
Simple. Yeah. But essential for, well, any global business now.
Yeah.
Okay, let's talk about finding information after you've processed it.
Yeah.
Scenario 4, question 4. This involves optimizing search within a document repository using Azure Cognitive Search.
Okay.
You want users to find relevant results, whether they use singular or plural terms like searching for policy or policies, and getting the same documents back. What feature of cognitive search helps you do that? And the answer is a synonym map.
Right. And this touches on a really important point about user experience in search, doesn't it? People type things differently. They just do.
Yeah.
A synonym map lets you define these relationships between terms. You can map car to automobile, or critically here, map policy directly to policies.
Ah,
So when a user searches for policy, cognitive search sees that map and automatically includes results for policies too. It significantly improves the recall finding all the relevant stuff without the user needing to guess the exact phrasing used in the original documents.
that's super useful.
Yeah.
You're essentially teaching the search engine a bit of common sense about how words relate to each other.
Precisely. It's a key tool for improving search relevance.
Now let's get conversational. Scenario 5, question 5. You're building a support bot with Azure Bot Service and needed to understand user intent from natural language input. Like figuring out that I need to reset my password means the user's intent is, password reset, which Azure Service is fundamental for this natural language understanding piece. The answer is language understanding, or LUIS.
Yeah, LUIS is absolutely the core service for building conversational AI that can interpret what users type or say. You train LUIs by giving it lots of examples of user utterances and telling it what the intent is behind them, like order pizza, check statuses, password reset, and also what the key entities are within those utterances, like pepperoni pizza, order number 123, my account.
Right, the specific details.
Exactly. So when a user interacts with your bot, LUS analyzes their input, predicts the most likely intent, and extracts those specific entities you defined. This is how your bot knows what the user actually wants to do and what specific information they've provided to do it.
So LUS isn't just simple keyword spotting. It's designed to grasp the underlying meaning and pull out the critical bits of information from conversational text.
That's it. It translates messy human language into structured data your bot can actually act on.
Speaking of building AI, let's look at evaluating models. Scenario 6, question 6, describes developing an image classification model with Azure Custom Vision. After training, you need to review its performance. The question asks for 2 key metrics you absolutely must review: the source list, precision, and recall.
Yes, precision and recall. They're fundamental for understanding how well your classification model is actually performing, especially in scenarios like image classification, where you're trying to identify specific objects, right? Precision tells you, of all the times the model said cat, how often was it actually a cat? It's about minimizing false positives saying it's a cat when it isn't.
Okay.
Recall tells you, of all the actual cats in the images, how many did the model successfully find? It's about minimizing false negatives missing the cats that were really there.
So precision is about the accuracy of the positive predictions, while recall is about finding all the actual positives. Why are both so important? Why not just one?
Because there's often a trade-off between them. You can build a model with very high precision by only making a positive prediction when it's extremely confident, but then it might miss many actual positives, giving you low recall.
Right, too cautious.
Or you can build a model with very high recall by being really aggressive with positive predictions, but then it might incorrectly flag many negatives as positives low precision.
Too trigger happy.
Exactly. The right balance depends entirely on your application. For medical diagnosis, you probably want very high recall, right? You don't want to miss anything. For spam filtering, maybe precision is more critical. You don't want to block legitimate emails. Reviewing both gives you that full picture of performance.
That's a great point. The specific use case really drives which metric you might lean towards prioritizing. Okay, moving on to a really critical modern AI topic, responsible AI. Scenario 7, question 7.
Yes, important stuff.
This involves designing an AI system for internal HR analytics and needing to meet the responsible AI principle of fairness. What's a key action you should take? The correct answer given is ensure model accuracy is consistent across groups.
And here's where it gets really, really important for real-world impact. Fairness in AI, as it's defined in many responsible AI frameworks, essentially means that your model should perform equitably across different demographic or sensitive groups. Could be gender, age, race, things like that. If your HR analytics model is significantly more accurate for one group than another, its decisions, maybe predicting job performance or identifying candidates, could unintentionally perpetuate or even amplify existing biases.
Right, that makes sense.
So ensuring consistent accuracy means checking that the model isn't systematically disadvantaging or favoring any particular group based on one of those sensitive attributes.
So it's about checking that the AI isn't inadvertently working better or worse for different sets of people, which could easily lead to unfair outcomes down the line.
Absolutely. It's a tangible way to measure if your model is potentially introducing or amplifying bias. Critical check.
Let's circle back to LUA for just a moment. Scenario 8, question 8. You're training that LUAS model for a food ordering bot again.
Okay, back to pizza.
Right. And you needed to recognize specific food items like pepperoni pizza, veggie pizza, and cheese pizza as distinct pieces of information to pull out. Which LEAS feature handles identifying these specific data points? The answer is entities.
Right. So LOAS identifies intents. That's the user's overall goal, like order food. But then it extracts entities, the specific details related to that goal. In the earlier example, I want to order a large pepperoni pizza and a side salad. The intent is order food, but you need to identify large, maybe that's a size entity, pepperoni pizza, a food item entity, and side salad, another food item entity.
I gotcha.
LOAS entities are how you define what kinds of information you want to extract. Then you train the model to find specific values for those entities within the user's input. You create a food item entity and train it to recognize pepperoni pizza, veggie pizza, etc. as possible values for that entity.
So entities are like the structured variables you pull out of the freeform text, making the user's command actually actionable for the bot.
Precisely. They give the intent context and all the necessary specifics.
Okay, let's broaden out to general text analysis now. Scenario 9, question 9. You're building a language analysis pipeline using cognitive services and need to extract key phrases from customer reviews. Basically, finding the most important topics or terms customers keep mentioning. Which Azure Cognitive Service is designed for this? The answer here is text analytics.
Yeah, text analytics is a really versatile service within the Azure Cognitive Services suite. It offers a whole range of capabilities for understanding text. Key phrase extraction is one of its core features.
Okay.
You can feed it a large volume of text, like customer reviews or survey responses, and it will identify and pull out the most relevant phrases, topics, or concepts being discussed. It's super useful for quickly summarizing feedback, identifying common complaints or praises, or spotting trends in text data without having to read absolutely everything manually.
That sounds perfect for getting quick insights from huge amounts of unstructured text, like you said, surveys or reviews. It stops you from just drowning in data.
Absolutely. It turns those piles of text into something much more like actionable insights.
Finally, let's talk about keeping AI models performing well after they've been deployed out into the wild. Scenario 10, question 10. You're visualizing AI model performance in Azure Machine Learning after deployment and need to monitor how the model's predictions, or even the incoming data itself, might be changing over time. Which built-in feature in Azure Machine Learning helps with this crucial task? The answer is model drift monitoring.
Ah, model drift. Here's where it gets really interesting for models living in the real world because they don't stay static. A model trained on a certain data set kind of assumes future data will look similar.
Right, makes sense.
But in reality, patterns change all the time. Customer behavior shifts, data collection methods might evolve, external factors change the distribution of your data. This is what we call model drift.
Okay.
And it causes your model's performance to degrade over time because the relationship it learned initially is no longer quite valid for the new data it's seeing.
So it goes stale.
Exactly. Azure Machine Learning's drift monitoring specifically tracks your incoming data and the model's predictions, comparing them back to the original training data. It alerts you when significant changes, significant drift is detected. This basically tells you it's probably time to retrain your model on fresh data to maintain its accuracy.
So model drift is kind of like the AI version of things change in the real world, and this monitoring feature is your early warning system that your model is getting out of date and needs an update.
Precisely. It's essential for maintaining the actual value of your deployed AI systems over their lifetime. And maybe what's one more question you have about how that specific service, the one that caught your eye, actually works in practice, something to mull over.
Yeah, definitely food for thought.
That's
Thanks for
it.
bringing these sources and joining us for this deep dive.